A camera is placed 3,000 feet from a rocket launching pad. This sounds familiar. Wait a minute. Is this the same problem? Okay, so it's almost the same. It says how fast must the elevation angle change at that instant to keep the rocket in sight? Interesting. So we're still using the same diagram, but they're asking a very different question. So I'm going to keep this the same, and this the same, and this the same. Okay, I'll try to recreate my masterpiece rocket here. It's going to look like a ghost. Sorry. Okay, that's the rocket. Alright, so how fast must the elevation angle change? So I guess we don't really need C. They're not asking about that distance anymore. We need B still because the 4,000 feet is still the vertical height. But they're asking about the angle, theta. So that means we're going to be using one of the SOHCAHTOAs here. We'll get to that. Let's write what they want. So they want the rate that the angle is changing. So d theta dt when B equals 4,000. And we still know that dB dt is the same rate as before. Okay, so that's all the information we're want to find, and what we know. So let's go ahead and set up which equation we'll need. So from theta we have opposite and we have adjacent. So do you remember which one that is? Yeah, that's going to be tangent. So tangent theta equals opposite over adjacent. And so now we're going to take the derivative of this. So the derivative of tangent, I hope we remember, is secant squared of that function times, using the chain rule, d theta dt. Okay, and then this on this side, we can kind of think of it as 1 over 3,000 feet, kind of as the coefficient, so that it's a constant multiple, times the derivative of b with respect to t. So we don't need to do the quotient rule there when the denominator is a constant. All right, so let's actually figure this out. So remember previously, we can plug in the 4,000 after we do the derivative. So if we think of this as 4,000, and we know that this one's 3,000, I'm going to need the hypotenuse for secant, because it uses the hypotenuse, so we've got to remember this would be like a 5,000. So secant is let's see, that's going to be 1 over cosine, so it's going to, instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So we're going to have 5,000 over 3,000, which we don't need those zeros. That simplifies to 5 over 3. Oop. So 5 over 3 squared times d theta dt, which we don't know because that's what we're going to solve for, equals this constant. And then our dB dt is 880 feet per second. All right. So this is going to turn into just so much fun. Well, let's go ahead and square this. That would be 25 over 9. And this would just become an ugly fraction. So we would have 880 over 3,000. And then we would have feet per second over feet. So the feet are basically going to cancel out here and just leave me with seconds on the bottom. So the only way, I guess the easiest way to do this one as far as solving is let's just multiply by the reciprocal fraction so that we can solve for, that is not supposed to say dB. Ooh, sorry. That's supposed to say d theta. Maybe it was a theta and I was bad at drawing it. I'm not sure. Okay, so yeah, we need to multiply by the reciprocal fraction. So we'll put 9 over 25, multiply that on both sides. All right, and that's going to take us to finally having, These will cancel out and leave us with d theta dt, what we were trying to solve for. And then this nastiness all simplifies to 66 over 625, and it's going to be radians per second. Okay, and the reason it's radians is because we got this from the triangle, and we're doing it in measurements of radians instead of degrees here. We could probably we could put it in degrees if we really wanted to, but all right. So now we can finally write our sentence, or maybe we'll see how this goes. So we'll say the elevation angle. I guess I'll try to write it over here. The elevation angle must change at a rate of 66 over 625 radians per second to keep the rocket in sight. When the rocket is 4,000 feet in the air. Woo, we did it. All right, so those are the 4 first fun examples you get to go through, and we will do the other 4 tomorrow in class, and then that will complete our practice and lesson on related rates.